Graphing absolute values functions are similar to graphing reciprocal functions in that you would graph the function inside the absolute value bars first. Then what does an absolute value do? It makes a negative value positive. So absolute value of negative 5 becomes positive 5. So what you do after you've graphed f of x, you look and say, where are my y values negative? I need to make them all positive. And what that does is it essentially takes that negative section and flips it over the x-axis. So in this graph, the entire graph will be above the x-axis. So we'll do a couple of examples. I'll probably add some to the ones that we already have. Oh, I'll go back. I know you were writing. Given f of x equals x squared minus 4, graph the absolute value of f of x. So we start by graphing f of x. Well, it's a parabola. Move down 4. We've got negative 2, 0, and 2, 0, and 0, negative 4. Are they being mean to me? All right. So we graph f of x first. And then all the absolute value is going to do is change negative y values to positive. So 0, negative 4 is going to become 0, positive 4. In fact, this whole section where the y values are negative is going to get reflected up. So we still have 2, 0 and negative 2, 0. And that bottom section just gets flipped over the x-axis. Part B to this one, and this sometimes happens on the exam, so it's good to see it before it happens, is could you graph the absolute value of f of x and then minus 1? Well, what does a minus 1 do to a graph when it's outside it? Just shifts it down 1. So we would graph the absolute value of f of x just like before, and now we're going to take that graph and move everything down 1 unit. So instead of having 2, 0, we have 2, negative 1. And instead of having negative 2, 0, we have negative 2, negative 1. And instead of having 4, 0, it's shifted down 1. 0, 4, we have 0, 3. This part is still like this. And sometimes this causes students pain because part of the graph now is below the x-axis. Okay, but why is that? Because there's a minus 1 afterwards. The absolute value is always bigger than 0, but when you subtract 1 from 0, it could be negative. So we could have a question where there's an absolute value and then a translation afterwards. Or sometimes they give you graphs like this, negative absolute value of f of x. Well, the absolute value would make it all positive, and what would that negative do in the end? Make it all negative. So this one in this graph would look like that. Because it would take your graph that you did originally, then flip it all back down over. Often absolute value questions will give you the graph first. So here's one. They wouldn't have to give you this graph, because you could graph this from your polynomials functions unit. Given that f of x equals x times x plus 3 times x minus 2, you would have known that you have x-intercepts at 2, 0, 0, 0, and negative 3, 0, because it's already factored. And you would have known this was a positive x cubed graph, so its end behavior acts like a line with a positive slope. What's going to happen when you do the absolute value of this? All the sections that are negative, they get flipped up. And all the sections that are positive stay exactly the same. So the effect of an absolute value on an entire function is it takes all the y values and makes them positive, but this has the effect of changing any part that's below the x-axis gets flipped up over the x-axis.